My name is Kane Wilcox, and today I'm going to share with you how we're using 12D to help solve the housing shortage in Auckland and New Zealand. What this means for you is that I'll run you through our approach to design and construction using 12D model and also 12D synergy, and show you how it's at the core of our alliance. How this will enhance your organisation is by providing you with insights on how to design and develop brownfield sites, while also providing innovative ideas and efficiencies for your next project. Firstly, a little about me. I'm a senior civil engineer and design manager on the Piritahi Alliance, which is the largest urban regeneration project in New Zealand's history, and have over 15 years experience in the civil engineering sector. I am the design lead for one of the biggest neighbourhoods in the groundbreaking project that's removing 7,000 old state houses across Auckland, remediating the land and upgrading the infrastructure to enable 33,000 new homes to be constructed in the same space. Currently, I lead a team of 8 engineers and drafters who work with many other disciplines. I have quite a few years' experience using 12D and believe greatly in passing on my skills to elevate other team members and help them upskill. And although I'm not always on the tools 24/7, I'm still pretty efficient getting into the design if required. My home company is Grierson, and currently I am being seconded out. At the moment, I'm recording this in the highest alert of lockdown. We are only allowed out for essentials, which is just the supermarket and chemist. My office is a bedroom. I'm leaning up against a set of drawers, standing on a few planks of wood, and have 2 very young kids terrorizing me throughout the day that you might see or hear. There are 3 main topics that I'm going to speak about today. I'm going to provide you with a high-level overview of the alliance and project and what the constraints and issues are. I'm then going to show you how we tackled them with some examples in 12D model. And finally, I'm going to run you through some of the innovative ideas and efficiencies we are using. The Piritahi Alliance comprises of Kāinga Ora as the owner partner, 3 engineering consultants, Harrison Grierson, Tonkin and Taylor and Woods, and 2 contractors, Dempsey Wood and Hicks Brothers. The type of work we do includes detailed civil design and construction, removal of old houses, land remediation, arranging consents related to earthworks and infrastructure, construction of roads, parks and utilities, and looking after the communities we're working in as we go. We basically provide all services up to the boundary of each super lot, ready for the build partners to connect to. And we also remove any contamination such as lead and asbestos in the soil to ensure the site is safe and deemed clean. This is the largest urban regeneration project in New Zealand's history. To give you some context on size, let me run through some stats with you. Our program covers 52 square kilometres. To put that in perspective, on the current slide we have overlaid our work in green and blue, and it covers Manhattan Island in New York, which is approximately 59 square kilometres. It is also half the size of Hamilton, a city in the North Island of New Zealand, which is 110 square kilometres. Currently we have 6 what we call precincts on the go: Northcote, Roskill, Mangere, Tamaki, Hobsonville and Oranga. Within those precincts we have approximately 20 smaller neighbourhoods such as Northcote, Oraka, Roskill, South, Wesley and Wokofi. We have a total of 85 TOCs, target output costs, basically agreed fixed prices that we need to build to. This is a mixture of master planning, construction only and DNC. Regarding consents for the last calendar year, we lodged 20 and have 15 approved. Some of these are global consents as well, which treat very large development areas. Similarly, with the EPAs, we've lodged 58 and have 57 approved. We also have handed over 116 super lots, which has enabled approximately 1,900 new homes. We're turning over 130k a day just in design. That's over the 3 design companies. And we have completed $23 million of work just this last month, all up. This was including construction, and the design component is about 10 to 15% of that. Having the opportunity to work directly with construction is a very unique and helpful situation. There is a no blame and no troublemakers culture. Currently we have 142 full-time design staff, 50 from HG, 56 from TNT, and remainder from Woods. This slide shows one of the 6 precincts, and within that precinct I will be showing you how we tackle the Oraka neighbourhood, which is shown in red. I will run you through a few of the major constraints. Location-wise, Oraka is at the base of Mount Roskill, and the existing geotech conditions are topsoil for the first 300 millimeters, then solid unfractured rock for the majority of the area 10 to 15 meters deep. This neighbourhood was generally built in the mid-1940s after World War II, and at the time they constructed the sewer network but connected the stormwater drainage into the same combined sewer network. This meant that in a peak storm, prior to us upgrading the networks, it would overflow twice a year to the nearby Oakley Creek. One of our primary goals is to separate this network. Some of the existing stormwater network does go to soakage as well. The Oraka neighbourhood is a brownfield development and highly constrained site. The residents have had a 6-kilometre long Waterview tunnel as part of the Auckland motorway network constructed prior to us starting works on site as well. The main collector road is lined with a large claret ash trees and seen by the residents as a recognisable feature of the neighbourhood, and although not protected, is seen as trees of significant value, and we've done everything we can to work around them. With there being basalt everywhere, we need to keep the noise and vibration to a tolerable level for the residents. Kāinga Ora do not own all the lots, and we need to keep the services live for existing residents. And the road network needs to be operational as well, including traffic management. There is a mix of residents, private, state, and generally we are removing or relocating the existing house and replacing it with 3. One goes to Housing New Zealand, one goes to Market, and one to Kiwi Build program for the first home buyers. The Oraka neighbourhood is approximately 10 hectares in size, and we are removing 300 state houses to make way for 1,100 for this neighbourhood alone. We are also providing a new pedestrian shared path network throughout called a Green Link, and we have completed traffic coming on the main collector road. Stormwater-wise, we have provided hydrological mitigation by means of treatment and retention to comply with local standards. We have constructed 4.5 kilometres of stormwater pipes. This is for pipe sizes between 200 millimetres to 1650 diameter throughout the development. For Oraka, we have had a team of 7 to 9 drafters and engineers full-time for the neighbourhood since November 2019. We have used a broad range of main features of 12D, generally keeping it straightforward and simple, keeping a focus on upskilling my team and rotating them through different design areas of the project. We have split the neighbourhood into multiple disciplines for the 12D 3D projects: sewer, stormwater, roading, and existing survey. This has allowed multiple team members to work and collaboratively design at the same time. All 3D models are referenced out using shearing, tins, and strings. A large portion of the Oraka project is the stormwater and sewer network. We have created a 3D network of both using the water network editor. We output to CAD the long sections and plans and have basic chains that we run to automate the process. We found the easiest way to have one CAD file with multiple XREFs stacked on top of each other on different layers and then freeze off in the viewports, all inserted at 0,0 And then when we ran the 12D long sections, it didn't mess up the pagination if the length of the pipe changes. We have well over 20 pages of long sections per stage, so this is an important setup for us. The long sections are 95% complete from 12D. Sometimes we put in the odd dimension or label in CAD. We use the node diagrams in 12D regularly to export the manhole blow-up detail plans. These are an excellent feature and takes away a lot of extra manual drafting that would normally be required. I will show you a quick clip on the next slide as I talk. We also use the perimeter feature for a lot of incoming pipes into the manhole due to the size of the pipes. This is to offset the pipe from the center of the manhole. In New Zealand, we have standards that dictate a minimum separation between the pipes, for example. With the node diagrams, ideally we would like to be able to export the metadata from the angles that the pipes are coming in and out, and also the invert levels to either Excel or Notepad so that it can be exported for other uses that I will mention in the innovation slides. So just on screen there, we've got a little video clip that's showing how to use the perimeter feature. While that's playing, I'll continue to explain how we're modifying the stormwater network on the Alliance. We use the dynamic drainage within the water network editor, and we have set up the IFD table, and it uses the rational method to calculate flows for the stormwater. Our network is very flat, so it's important for us to show the pipe attributes for maximum flow and maximum pipe capacity, which is all part of the PPF output automated by 12D. We also show the hydraulic grade line on the long sections to visually highlight any issues. We also provide counsel with direct outputs of the hydraulics for review. They put this into other software as an added layer of reassurance to the design. The sewer network for a project is more complicated than usual. Because the existing network is combined, pipes are between 525 to 300 millimeters diameter. This was to cater for the increased stormwater flow instead of the usual 150 diameter pipes. The sewer network is laid at a very flat grade for a large portion of the network as well, and generally run in the backyard of properties, sometimes under houses. So what that means is that when we remove the stormwater flows, the hydraulic grade line is a lot less, not meeting the self-cleansing velocity, so we need to downsize the pipe. This is to prevent smells, etc. And as we don't own all the lots, we don't have the option of open trenching. The solution is slip lining the pipes, which is basically meaning sliding another smaller pipe within the larger pipe and then grout filling around it. Downsizing the pipe increases the depth of flow and increases velocity. In 12D model, we needed to do both combined flows before development and then separated sewer flows. For the combined flows, we used a spreadsheet where we calculated the sewer flows and then we put the flows into the network as inlet data, minor and major, under the nearest upstream node on the hydraulics tab. We then also run the stormwater component using the dynamic analysis, where we have all the stormwater catchments all drawn up prior and using the IFD table previously shown. This gave us the combined flows, and then we removed the catchments and reran the analysis to gain just the sewer flows. In the next slide, I have one of my team record the key steps in a short video as my team found it in a unique scenario.
So first step is you go onto the network, the water network editor, and you pick your string. Then you go onto the nodes subtab and then the hydraulic subtab. And then you put in your minor value and your major value, and then you hit analysis. And then you run your major first to get the peak wet weather flow. And then you run your minor to get your minor flow for your self-cleansing velocity. Then you go back to the editor, and then you go onto your drainage sewer section plot, and then you pick your view, you run your PPF, you then go back to your analysis page, you run your major flow, and then you plot your section, and you'll see that your pipe capacity, your flow is 28.436 and your self-cleansing is 1.09. You then run your minor flow and you plot your section. You then see that it's reading the minor flow of 12.529 and 0.89. You want your section to be reading the minor flow for the self-cleansing and the major flow for the capacity, for the pipe capacity. The way you do this is on your PPF. You first go onto your string attribute editor, and then you pick your pipe. You then click on the pipe subtab and you scroll down to where you see calculated direct pit and pipe flow total major. You then copy that text, and in your PPF, you go on to where you have your sets set up, and for your peak wet weather flow, which is set number 9 in this case, you copy and paste the name for the direct total major flow, and then you plot your long section, and you should have your self-cleansing flow reading the minor flow and your peak wet weather flow reading your major flow.
As the site is basalt, we've also used 12D model to extract trench volumes. We've used the excavation quantities command. Once the stormwater network is built in 12D, it will run the template you create along the network and create a trench made up of strings. You then create a surface and compare your other surfaces with it to gain the volumes. The team has also used drone technology. We pick up 3D data as the construction team passes through the development. And then we look at how the initial design compares with the actual situation on site, and the findings has helped refine the estimate for the next stages. For the roading network, we have kept it fairly simple and used apply MTF for creation of the existing and proposed road network. We have, however, had to model some quite complicated Swedish-style bus-friendly raised intersections, which have a specific grade entry and exit ramp that we need to comply with. These are 300mm thick, and we use 50 MPa fibre reinforced concrete. And the idea is that they are long enough so that the whole bus can sit on top of the ramp before coming off it, rather than like a speed bump. For the stormwater management plan requirements, we had to show that we're treating 100% of the road runoff, and grading the flows off the raised intersection was key. The best way to do this was to model it in 12D model. It also had the benefit of being able to be outputted directly to the construction team as a 3D surface. We also had to create a short video with very limited time that I needed to help provide some visual aid for a meeting. We used 12D to output the services, and then one of the team members tidied it up in 3D Studio Max in less than 3 or 4 hours total turnaround. We've created working relationships with power and communication suppliers and we obtain the latest up-to-date data, and it comes in AutoCAD 2D format. As a starting point, we drape it to a set distance below the surface to provide an indication of critical services locations. We also convert using mapping files if required to provide services widths and also more intelligent data set to work with. In the Water Network Editor, we also use the clash detection under the Global tab to ensure that stormwater and sewer pipes in particular have no issues. Some of the teams have also been able to extract the Auckland Council GIS data and convert it to 12D water string network. This was a starting point to recreate the existing network. This is a bit clunky currently, mainly because of errors in the council levels or missing data, but saves a lot of time at our end. With Oaraka being a brownfield development, we had to come up with some complex services that we needed to alter. Two are shown on the slide. One is a transmission sewer manhole, and for safety reasons we cannot enter, so we used a 3D scanner and created a 3D surface. In this short clip, you can see the complexities with internal dropper pipes and how priceless having the software is so that we can accurately and safely determine the invert level of the pipes. Also, as shown on screen, we have a trapezoidal chorus comms chamber that has an existing steel ductile iron 100mm water main running through it. We also followed a similar process where we used 3D scanning equipment to pick up all the shapes. Then we recreated it as a surface in 12D and then was able to accurately thread it through our new pipe. The survey team have just purchased new BLK 360 as well. We've used 12D Synergy in parallel to using 12D model for this alliance. A lot of the main features we use are on this slide, and also Ryan Healy discusses them further in his Birds of a Feather session. One excellent feature we use in this 12D automation is the CAD title blocks. This saves a lot of time, and we find the Excel master file the easiest way to control everything rather than the layout tabs. We use the issue sets for anything that leaves the office so we can track from a QA point of view. There is automatic document transmittals generated with any issue sets sent out as well. And general check-in and check-out and rollback has been life-saving, especially for the younger graduates. We save and file everything using the email drop zone shown on the slide. 12D Synergy has been critical during COVID, and without it we wouldn't have been able to work. Two other features that we use regularly are the shareable links and the @name features. Once our neighborhood was designed in 12D, we really started to see some benefits with both importing and exporting data to other software platforms. The main examples are listed on the slide. We have our own in-house GIS system for Piritahi that is comprehensive and utilized regularly by all teams. As mentioned previously, we created a 3D video from 12D data, tidied it up in 3D Studio Max. We used ArcGIS storyboards for use in presentations and integrated with Revit for the build partners and architects and developers. Manhole data was exported for structural engineering design. 3D scans were completed using the BLK 360 and the BLK To Go. Arborist shapefiles for their own in-house GIS system was used. Drone data was used, and output to XB Storm by Innovise for flood modeling. OrgView is an augmented reality software that we trialed on site for a few months, mainly for two reasons. Firstly, for safety and prevention of service strikes, and also for planning of construction works. How it works in basic terms was that we outputted the 12D model at key milestones, and the data was fed into the GIS system, which has a live connection through to OrgView. You then go out to site and log in via an app on a phone or a tablet. It uses a camera on your phone or tablet and satellite position to orientate it. You can plug your phone into a handheld Trimble unit for high accuracy if required. Since trialing it, they've fine-tuned some of the data processes, and they have a 12DA translator to auto-generate a post-GIS schema and populate it with whatever is in the 12D file. This is now being used on multiple AllView projects in Australia. Also, by publishing the data as WMS WFS services, 12DA users can view and interrogate the data as it is uploaded. During my time as design manager for Oraka, my team and I have led innovation projects that have made large contributions to the 2.1 million in savings on the program since 2019. The rock breaking has been a major hurdle for the team, so we've employed multiple innovative methods. The team have used what we call pepper drilling, which involves using a large drilling rig with a 20 to 30 millimeter drill that drills down to the invert or base of the trench for services. This is done at 300mm centers either side of the trench, and then a 40-ton rock breaker and digger excavates the trench. The extent of the excavation is controlled and cracks run between the holes that are drilled like perforated paper. We also trialled chemical grout expansion to pre-crack the basalt. And for the stormwater network, we had to provide hydrological mitigation for the collector road, and we collaborated with the team at Stormwater 360 to use their Filtera units and modify the units to have another retention unit below it. This combination was a first in New Zealand. We've also had some innovative build partners such as Module come on board who prefabricate dwellings off-site and then drop them in complete. We have had our own in-house ArcGIS network that has fed data from the 12D model's boundaries and design data. We output ISC or 12DA format to the GIS team to integrate into their web portal at important milestones. It uses FME models to convert 12D designs to GIS, then display in our web portal. This GIS system is invaluable to the team and regularly accessed by all parties. Some of the benefits are shown on the slide, and I will show you a quick video on the connectivity with the CCTV system.
This is Piritahi's GIS system, and the 12D model that we've created has been directly inputted into this. And there is a traffic light system in terms of the condition of the stormwater and sewer pipes. As you can see from the legend, green is ready to be signed off, orange is under review, and red needs remediation. So I'm going to zoom into this stormwater pipe here that's orange. I'm going to click on it, gives you some metadata, and then I'm going to show you that if I go down and hit on the URL, it'll take me through to the Pipe Vision website, and it will take me directly through to the log and the CCTV for that particular pipe. Having that shown visually is extremely helpful for the team. So on the right here, I can maximize that video and watch the camera go through.
As an example of our approach to sustainability for the large stormwater manholes, we noticed that by the time we got them in the excavation hole, not a lot of the manhole riser was left. Having already modelled all the manholes in 3D and 12D model, we were able to quickly export out the finished levels and sizes and pass them on to a supplier who provided us with a perfect manhole product where the manhole base, riser and lid were poured as one piece. With COVID, the supplier was unfortunately unable to obtain molds for the larger sizes we needed, but we ended up using a product similar called Done Manholes for the sewer, which is now complete and in the ground. We see the precast manholes and the automation from 12D model to the supplier as the future of our industry, and would love to work with 12D to get this more streamlined and automated further. Having the manholes pre-made saves labour, materials, and eliminates safety concerns of workers entering confined spaces. During the course of the Alliance, we had some in-house training that has been tailored specifically to what we were doing. Dylan from 12D New Zealand has been outstanding helping us out. Similarly, we have had excellent support from Andreas, James, Charlie, and Flo. Finally, just wanted to close out and say that I love working at Piritahi, and this Alliance project has created a great space for me to be innovative, lead a large team, learn, teach, be challenged, and have some fun along the way. This is up there with one of the highlights of my career. We've been pushing boundaries, using exciting technology, and the team has had to be creative. This is an exciting environment for designers, and it makes the project really interesting to work on. If you're interested in coming and having a chat about being part of the Alliance, please feel free to contact me or visit the Piritahi website. Massive thanks to the Oaraka design team, Sean, Sine, Hamish, Hamza, Mandy, Neo, Avi, Mike, and Phil. And also Max, Marky, Rach, Cam, Sarah, Simon, and Ben. Support from 12D New Zealand has been terrific. Dylan, Andreas, James, Charlie at 12D New Zealand, and lastly Lisa and Ryan for putting up with me, and 12D Australia for giving Piritahi the opportunity to showcase our work.